Welcome! In this series of short videos, we will look at topics for the PowerBasic console compiler. Today we will look at creating an application to automate the monitoring of a folder for new files using a Windows service. In today's video, we're going to combine the code from two previous videos. The video we did on file and folder monitoring, and the video we did on the creation of a Windows service. With automation, the goal is to set a process going which can run completely and utterly unattended. And that's what we're going to set up today. In our code folder, we have a subfolder called Monitor. This is a folder we're going to be monitoring for files being created. So let's have a look at the code that's going to do all this. We're going to build up this program in stages. We are at the moment looking at the PB_main function, the first function that is executed when your application begins. To make this application as efficient as possible, we're going to be creating a thread function. The code within this thread function is what's actually going to be doing the work. We will create this thread function in a moment, but we're going to push on with the rest of the code inside PB_main. In order to make the development of this new application as easy as possible, we will first develop it as a standard console application, and then we will convert it to being a Windows service. So in the PB_main function, we need a loop, and this loop is going to wait until a user presses the escape key on the keyboard to exit the loop. At that point, the application will terminate. In order to do this, we will display a message on the console asking the user to press the escape key to shut down our service. We will then run inside a loop, waiting for the pressing of the escape key. Once the escape key has actually been pressed, we will exit the loop. And at that point, we can close down the thread. So let's go ahead and create this new thread function. Although we're not needing to pass any parameters to the thread, I've put a variable in just in case you need to change your application to handle a passing of a parameter. So the do_nothing variable basically does nothing. So the purpose of this thread is to monitor our folder for two things. I want it to look inside the monitor folder for a file called keyfile.txt. Should that file exist, it will delete the file automatically. And the second thing this process is going to do is to look for files with specific extensions, any file with a .dat extension. If such a file is detected, it will check the contents of the file using a file hash to determine whether we've processed this file already or not. If we have not processed a file already, this function will calculate the hash value of the file itself. It will then write that hash value into another static file. And this static file is the one that contains the list of the hashes of all the files we have already processed. We can use this to determine whether we have or have not seen the file already. So let's do the first part of the code. To monitor for this specific file, all we need to do is to use the isFile function. We can test to see whether the file actually exists or not. If the file does exist, we will use a try-catch block and attempt to kill the file, to delete it. So the file we're looking for is called keyfile.txt, and it will sit inside the monitor folder, which is a subfolder of the folder which our executable is running in. So wrapping around this code, we need to put a loop. We need to put a do loop in place to ensure that it will execute periodically. So with the do loop in place, it will execute our code, sleep for 10 seconds, and then repeat. As this is running in a thread, our thread can be interrupted by pressing the escape key. So let's try running the code now. So our console window has opened up with the message telling us how to shut the server down. So if we go into our monitor folder and we create a file called keyfile.txt, As the process is running every 10 seconds, we should delete that file very shortly, and there the file has been deleted. So our process is working and running in a 10-second loop. We go back to our console window, press the escape key, and the application has now terminated. So the first part of our code is working just fine. So we now want to tack on to look for a specific file extension. And we can do that, as we've done many times before, using the $$ command. We're picking up the file name by looking in the specific folder, which is our executable path and the monitor folder, and we're using $$ to say, give us all the files which have the extension of .dat. And while the file name is unpopulated, we will do nothing. But as soon as the file name has a value in it, we can check to see if we've seen the file before. In order to determine whether we've seen the file before, we're going to have to use some more include files. We're going to have to bring in some libraries to our application. And these are our file hashing libraries. These allow us to take the content of a file and boil it down to a hash number. We can then compare that hash number against the values in a file. So we're going to be creating a file hash record text file. So we will create a constant to specify the name of that file. So we're going to call it filehashrecord.text. So within these libraries, we have a function called processedFileAlready, which takes a number of parameters. The first being the path and the name of the file we want to hash. The second is an error variable should some error occur. The third is the file hash itself, which will be passed back by this function. And the final parameter is the path and the name of the file, which will contain all the hashes of all the files we have processed. Now we've referenced a few new variables here, so we're going to create them at the top of our function. So a variable for the file name, a variable for the file name path, a variable for the error should one occur, and a variable for the file hash being returned. So we'll need to create this processedFileAlready function at the end of our code. This function is taken straight from a previous video. We're taking in the 4 parameters. We're declaring some variables, including an array to hold the list of all the file hashes we have currently processed. We're calling a function in our library to pull back the file hash. We are handling any errors that may occur in the file hashing process. We're calling another library function to pull the hash file list into an array. This is the list of all the files we have already hashed. We're then scanning the array for the file hash we have just generated. If we find it, then we're returning the value true, which means we've seen this file already. And we'll return the value false if we have not seen the file. And if we have not yet generated a list of files that we have already hashed, we will just return the hash of the file we've just processed. So if this process returns false, then we have not seen this file already. Therefore, it would in theory be a candidate to do some processing on the file. After whatever processing needs to be done on the file, we need to record the fact that we have indeed processed that file. So we simply have to take the hash value we have passed back from this function and append it to the end of our record file. Again, using another function from one of our libraries to append it to the end of the file. And once we get that far, the last thing we need to do before the while loop ends is to generate another file name using the dir command. So we now should have all the functionality within our application to scan for the 2 types of file, one to delete and one to record to see whether we've seen it or not before. So let's do a quick compile to make sure it compiles cleanly, which it does, and we'll try running our application now. So our console window comes up quite happily. We can go into our monitor folder, and at the moment there are no files in here. So if we create the first type of file, the keyfile.txt, and this file should be deleted within 10 seconds. And there it is, deleted. So if we create a new file now with the extension .dat. Now, as this file is not keyfile.txt, the process should not delete it. But the process should generate a file hash record, and it has indeed done that. We now have the file hash record file appearing in the folder. If we have a look, we can see the hash value of that file. As the hash value is generated based on the content of a file, if we then go in and change that content, it will consider it to be a new file. Although it has the same name, the content of the file has changed. So if we open that file up, put some data into it, and hit the save, the process should update the file hash record in another 10 seconds or so. And we should then have 2 records within that file, which we do indeed have. So our process to delete and to generate hash numbers is working quite nicely. And if we press the escape key, it will exit from the console window and terminate the application. So we've achieved the first part in having a console application whose job it is to monitor a folder. So how can we turn this in to a Windows service? The difference between your console application and a Windows service is that the Windows service is installed so that when Windows begins, this service can automatically start. It will run in the background until you decide to end the service. So let's go back to the code and convert this to a Windows service. I'm going to put some instructions at the top which we'll cover as we come to them. And we're going to add some more information at the top of our application. First of all, we need to give this service a name. We need to give it a display name and a description. So I'm going to set 3 constants up to hold that information. So calling our service name AAA Monitor Folder Service. We're giving it an appropriate display name and an appropriate service description. As we may want to do testing on this application later, we need the ability to make the application compilable either as a service or as a console application. So we're going to create a new constant. This constant can be commented out when we don't want to compile as a service. And we're going to do a bit of conditional compilation when we want it as a service. And we're going to include a specific include file that will contain our service code. In order to compile this successfully as a service, you'll need to make a small change to the way you compile. If we go to the Windows menu option and click on Options, and then the Compiler tab. At the moment, this is compiling using the standard Windows API include files that ship with PowerBasic. I'm going to amend it to use the Windows API include files that come from OZRocker. There's a link at the top of the code to where you can download these from. Once we OK that, it will compile quite happily using our new libraries. So because we're switching this to a service, there's a little bit more we have to do to make some conditional compilations. If we go to our thread function, I'm going to replace the section of code where we start the loop. If we're compiling as a service, then we're doing a do loop until this function returns true. This is a function that comes with one of the libraries. This is the one looking to see whether the service has been ended. And if we have a look in our PB main function, there is another initialization we'll have to do to set up our service. And we're calling this PB init with the names of our constants we'd set up at the beginning of the program. The service name, the service display name, and the service description. So if the compile as a service constant is not defined, it will compile quite normally as a console application. So that should complete the changes to our application to allow us to compile as a service. So if we do a test compile on that now, and there is our exe. Now that we've set it up as a service, how do we actually install it on your computer as a Windows service? In some programming languages, this can be quite complex. You need to create an installation package. Well, with PowerBasic and these particular libraries, the installation and deinstallation are within the executable itself. If we have a look in the folder in which our code exists, there is our service folder monitor.exe. Now we'll need to open a console window here. This can be done quite easily by pressing the Windows key and the letter R, and then typing in command.exe. But before you press the Enter button or the OK button, if you hold down the Control key, hold down the Shift key, and then press the Enter button. This will allow you to run the console under the administrator. Then all we need to do is to change directory to where our executable resides. So we will switch to the H drive, and we will change directory to where our code sits. And there are all our files. And this is the executable we want to install as a service. This can be done very easily. We type the name of the executable, then a dash, and then the word install. And the service will be installed. We'll leave our console window here, just minimize it for the moment. Now, having created and installed the service, we now have to start the service. If you go down to the taskbar, go into the task manager, you can quite easily pop into services. As we named our service AAA, it pops to the very top of the list. And you can see at the moment, this particular service is currently stopped. If you right click on the service, you can click the Start option. And our service is now running. As it's running as a Windows service, this is quite invisible to the user on the machine. Nothing the service does will be visible to the user. There will be no message boxes, there will be no windows popping up. So we minimize this for the moment and go back to our monitor folder. Now if we create another keyfile.txt file, if the service is running, it should within 10 seconds delete this file. And there it goes. So we know the process is running in the background. Let's just double check to see if we can create another .dat file. And we will put some text into this and save it. Now if the background process is running successfully, it should pick that up within 10 seconds, realise it's a new file it has not seen before, and update the file hash record. If we look at the date time modified, we'll see that it's just been updated. And if we open up the text file, we'll see there is now a third entry. So since our application is running as a service, we can start and stop it quite happily by going into the services. We'll see the service is currently running, and we can right click and stop the service. If we go into the Open Services and look at our service again and look at the properties, we'll see at the moment the startup type is currently manual. That would mean your service will only start when you go in here and click Start. You can change this to automatic or automatic delayed start. This way, every time the computer reboots, your service will automatically begin. This gives you a lot of flexibility if you wish to run something in an automated mode. And your service will run quite happily on either a desktop or a Windows server. So how do you delete it? How do you uninstall the service? If we close this down and go back to our console window. In our console window, we press the Up key and we change the -install to uninstall and then hit the enter button. And that is the service uninstalled. If we go back to our services, and if we have a look on the screen, you'll see our service is no longer on the list. So what we've achieved today is we've created an application which can be compiled either as a standard console window to allow you to test easily, or to be compiled as a Windows service, which can be easily installed and uninstalled from the console window. Being a Windows service, this can be run either manually, whenever you need it, or it can be set to run automatically every time the computer boots up. And the code within the application can be set to run any automation that you need to do. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.